Hello and welcome. Our little trip is going to take us to PHP Fairy Tale Land, where we will encounter some stories about PHP design patterns. One of which is The Dog That Knew Too Much, Garment the Fat Cat, and other stories from a land beyond our timestamp. We'll start our little journey with the story of Garment the Fat Cat. Long time ago, in a kingdom far, far away, there was a city of eager kittens. All were very diligent, prepared their tax papers beforehand, and were always busy preparing for everything that might or might not occur during the day. It was in this town that on Cheeseberry Hill there lived a fat cat named Garment. Garment didn't chase mice. He didn't shave on weekends, and never did more than absolutely necessary. Garment was working as a bus driver. One day he noticed that all his fellow colleagues were very eager to work. They stopped at every station in case somebody might want to get off, and they unloaded all the baggage in case somebody might want to claim it, all the burger boxes, shopping bags and holla kitty cases. And when nobody did claim anything, they loaded it back on the bus again. All shopping boxes, holla kitty bags and burger cases. They had a lot of stress, and still were barely on schedule. A lot of them were even close to burnout. It was on this fine day that Gum decided never to stop his bus, unless somebody signaled him to get off or on, and he unloaded baggage only when he was asked for it. Now from this day on, Gum was always on time. He was getting many happy customers and still had more free time than the others. It wasn't taking too long until Mouseburger Network found out about it and made him Kitty of the Month for services rendered to the public transportation system. It is said that in an interview with beautiful Jackie McMouse, he did answer the following famous sentence: "Don't work more, work lazier." Now, time to look at Garment's implementation, shall we? Well, we often come across the same problem that the Garment is having. You have a class that has some element that must be initialized prior to use. So your first approach will usually use a constructor that is doing some complicated and time-consuming stuff just to initialize the element in question. In this kind of time, it would be the package that could be claimed later. So the element baggage is claimed, is loaded beforehand, even if this is complicated and time-consuming. Well, this is called eager loading and leaves us with one problem, because if the baggage is never claimed and the object is destroyed without ever using it, it means that all your hard work was strictly for the birds. You may have known and seen this in practice. You have some running application that is pretty fast, but then you start to add little add-ons and little plugins and some more classes to it, and slowly but steadily your class or your software is becoming slower and slower, up to the point where it is almost impossible to use it. But there is a way around that. And this is called lazy loading. Now this is Garment's bus. You see that the constructor is totally empty, he does nothing beforehand. Instead he has a claim baggage function that just makes sure that the element baggage is initialized just in time and only when it is actually needed. This reduces the number of required operations and make your applications run a little bit faster. So to go with Garment's code, before starting to optimize your code, try being a little lazier instead. Our next little story from Fairy Tale Land takes us to the bridges at No Name Space. By using the design pattern, we come up with a recipe for beautiful architecture. Now, design patterns are nothing but recipes that try to ensure that not all your meals end up in a big ball of mash. So let's start by going with a recipe for gorgeous soup, shall we? It contains one piece of an abstract class, please note shopping, one well-sorted interface, several derived classes, and yes, just shake, don't stir. The interface contains all public methods that are common to all classes and is implemented by the abstract class. Look here. Nice, huh? Now our abstract class implements the animal interface in that case and implements all methods that are identical or should be reused in all subclasses. Just be careful when adding some flavor, because this class should not be doing too much or not enough at all, and don't introduce any more public methods that the interface does not have. Now to the derived classes. The derived classes must implement all the methods that the abstract class does not implement. In that case, it's the function and nouns for our dog, cat and dolphin classes. Now one thing you might want to keep in mind when using one of these classes, if you go for the type engine, use the interface, not the abstract class, not the derived class, just the interface. This will allow you to inject just any implementing class, not just one. Now actually in practice it will look something like that, and this is actually one of the basic patterns that you will encounter over and over again. You have an abstract class and you have some derived classes. Now you use an interface as a bridge between the user, which is the using class, and the implementing classes, which are the derived classes. This is called a bridge pattern. So much for today's recipes. Join us again for our next show and we will try the red wine. Oh, not so fast everybody, we got more stories coming up. Our next story is something that I have been told by a friend of mine. He was saying, when we were talking about abstract classes, I said, well, it's a little bit abstract for me, may I tell you a story instead? I said, okay, go on. I said, well, all these abstract classes seem fine for building hierarchies. For example, if I got a dog, and the dog is also an animal, and I know all animals can play, and so can the dog, and I said, okay, go on, I'm listening. He said, well, once upon a time in a land far away, there lived some wise dogs. When other dogs knew how to play soccer, these dogs knew how to create a new ball. They knew how high the ball was flying before the ball knew it, and in fact, sometimes they even told him. They were self-supporting and could fill their own bowl, right after they created the food for it out of thin air. And while other dogs could spawn little doggies, they could do their own, but that's beside the point. Okay, I said, I get it. So your code may look something like this. You got a dog that is an animal, and it creates its own ball, and it says how high it is flying just before it catches it. But yep, that's about it. Well, it's pretty good use for an abstract class here, right? I said, oh, that's true, but there's one thing. I think your dog would have been killed because he knows too much. Why so? Well, I think your god is almost a god object. He creates and destroys the things of the world and knows the consequences of its interaction with them in advance. You mean my dog can do too much? Oh yes, it needs at least 6 paws on the trunk. Oh well, any suggestions? Well, your dog should not have more paws than a regular dog. Leave the implementation of their interaction with the world to a facade. Here, look, a dog behavior facade. Neat, huh? Now we had to get a facade, and the facade takes a dog and a toy as input and implements all functions that have to do with playing with the toy. So all the interaction between the dog and the toy is left to that class, meaning that you can now implement also an Alphonse dog facade, or maybe an Eric dog facade, or a Puppy dog facade, and they all can implement different behavior and still be based on the same object, which is a dog. Well, it doesn't quite convince me yet, he said. Well, how about another example? If you got a car, well, he said, yeah, I got a car. So, a car is a complicated thing. Now, if you want to start the car, you don't really care what happens inside it. You don't really care what the motor has to do to ignite the engine. You just want to turn the key and the car should start. That's what you're thinking about. So, and all the complexity of the interactions between the object is kept away from you under the hood of the facade? He said, well, it always felt dirty rolling specific implementation to my beautiful classes, so the facades look awesome, almost worth killing a puppy over. I said, well, you're a true PETA activist, aren't you? So let's conclude our little story by one quote of Alphonse the dog. I have no idea how my car works. All I do is turn the key on the facade and it starts the engine. Oh, well, kinda sorta. Now our last story for tonight is about Harry. Harry the Flat Red. Harry the Flat Red is a null object. So once upon a time there lived... okay, let me rephrase that. Once there was a flat red named Harry. Harry inhabited the quiet place on Route 66, and he was a very friendly animal, cause he never complained about anything. So while other rats had side effects like missing cheese or secretly spread chainmails, Harry was, apart from the smell, not influencing his environment at all. For this reason, Harry was the perfect test subject, since he never had any influence on the real outcome of the experiment. Harry was the one multiplier, the null adder, and the neutral element of neutral elements. Harry had worked as a control group for non-barking dogs, as a copier of files that didn't copy a file, and as a mailer that didn't send mails. And seriously, the best pet I ever had was Harry the Flat Red. Now, how to adopt a Harry? Well, there are some classes that are difficult to test, like this bad dog class here. You see that if you ask that dog to speak, he does not only say woof, but he also creates a new mailer class and asks it to send an email. Now the unit test should not really send an email, or should it? Now it is time for Super Harry! Now what we are doing here is creating a Flatred's mailer. This Flatred's mailer is implementing the same mailer interface, and when it is asked to send an email, Harry does what Harry can do best. He plays dead. Now our good dog is actually accepting a mailer interface as input, meaning that now we can smuggle in our Flatred's mailer as well. And when then asked to speak, our dog will simply say woof. So using the null object here ensures that no emails will be sent during the test. And this makes testing a lot easier. So finally our experiment, or our unit test in that case, will have no unrelated side effects. So next time, instead of spending 1 hour after the other on every unit test, consider getting a flat red. Well, this concludes our session for today. So long and thanks for all the fish, and in case you want to visit us online after the show, go to www.janaframework.net or visit my Twitter account at janaframework. So long, thanks for all the fish, we'll see us later. Bye!